So what are we discussing? We are discussing rays to be considered for image formation. You can write the topic. Any two rays from following can be considered for image formation. So we have learned which two rays so far? The ray traveling to principal axis after reflection passes through focus, and then the reverse. The ray passing through focus is parallel to the principal axis after reflection. Third ray is ray incident along center of curvature returns back on the same path after reflection. What are we saying? If the ray is incident along center of curvature, then what should happen? So it will retrace the incident path. Can anybody tell me why?
Normal.
Yes. So normal में angle of incidence क्या है? What is the angle of incidence when the ray is incident along the normal?
90.
The reflection. Normal के साथ एंगल होता है इंसिडेंट रे का, तो 90 डिग्री होगा. देखो ऐसे ही होता है, ये नॉर्मल है, ठीक है. एवरीबॉडी लुक हियर. अभी अगर ये इंसिडेंट रे है तो एंगल बनता है आई. अभी इंसिडेंट रे कम किया तो एंगल कम हुआ. अब एंगल क्या हुआ व्हेन द रे इज इंसिडेंट अलोंग द नॉर्मल? जीरो हुआ ना. 90 क्यों बोल रहे हैं? 90 कब होगा? जब ऐसे हो, ऐसे. ये बहुत बड़ा कंफ्यूजन है. ऑल्दो ही सेड इट, बट ये सबके साथ होता है. What you do is when the ray is incident along the normal, तुम बोल देते हो 90 डिग्री, जबकि एंगल कितना बन रहा है? This is the angle 0. ठीक है. तो एंगल ऑफ इंसिडेंस इज इक्वल टू एंगल ऑफ रिफ्लेक्शन. अगर इंसिडेंट एंगल 0 है तो रिफ्लेक्टेड एंगल भी 0 होगा. इसलिए अगर इंसिडेंट डायरेक्शन इज अलोंग द नॉर्मल, तो रिफ्लेक्टेड डायरेक्शन विल आल्सो बी अलोंग द नॉर्मल. 0 0. तो आप देखो, तो कर्व सरफेस में यानी स्फेरिकल मिरर में नॉर्मल क्या होता है? रेडियस है ना. द रे पासिंग थ्रू द रेडियस, तो ये वापस से रिफ्लेक्ट होके वहीं से आएगी. ओके, क्लियर. सो दिस इज द थर्ड रे. फोर्थ रे में we will take, now this is your CN. So any ray incident at pole, ठीक है. So what is the angle of incidence? This is the normal itself. Principal axis is also normal because it is passing through center of curvature, right? So what is the angle of incidence? This. Then you construct the ray, reflected ray on the other side of the normal, making same angle as phi. Okay? So these are the 4 rays. Out of these 4 rays, you can take any 2 rays for image formation. Okay? So mostly we take this, sometimes this, and this. Matlab any 2. From 4, any 2. And we'll see how we use that. Okay? So first you, and same holds true for convex mirror. Convex mirror, maybe you can take all these 4 incident rays and their reflected nature. So for convex mirror, what will happen? देखो. So if this is convex mirror, where is C? Here. Where is P? Here. So where is the principal axis now? This is the principal axis. So when you take, and this is F. So in case of convex mirror, when you take an incident ray parallel. So in this case, after reflection is went through focus. यहाँ पे क्या होगा? After reflection, it will go away from focus. Because normal is this only. So after reflection, it will go away from focus. So when you extend it backward, that's when it will go to focus. Got it? So यहाँ पे it is going away from focus. Here it was going towards focus. ठीक है? So again, if any ray is incident along focus after reflection, it will be parallel. Second is, let's say the ray is incident along focus, then after reflection it will be parallel. Second case. So any ray incident along the center of curvature, let us say like this, after reflection it will return back from here also. Okay? And any ray which is incident at pole after reflection, it will make same angle on the other side of the principal axis. So all 4 cases are true for convex mirror also. Okay? So now we'll go into image formation. So quickly make these diagrams. So neat ray diagram with direction of angle of incident, direction of incident ray, direction of reflected ray. Good. So ये ऐसे होना चाहिए, ठीक है? And mirror का coating भी लिखना चाहिए. Coating is not shown in all diagrams. Shade है ना, back side. So we will do that. We will have the coating to do. So you can make freehand diagrams right now to save time. Everybody done with the diagrams? In the meantime, if anybody has any doubt, confusion, please ask. Feel free to ask questions.
So do we have to draw that?
Second one, for convex mirror.
Yeah.
Now you can do that. I just gave you an example. एक ही diagram बनाया मैंने खाली 1 का. As an exercise, try for 2, 3 and 4. बना के देखो. I've already explained कैसे बनाया. Draw the diagram for all the 4 rays for convex mirror as well. Similar ray diagram for convex mirror. So, what was the description for 4? I'm writing the description here. Ray incident obliquely at pole is reflected on the other side of principal axis making or at an angle same at an angle same as angle of incidence. Okay, so these things you have to keep in mind while drawing the wave diagrams. Do I erase the left side? So we are discussing image formation by concave mirror. Okay, so the first is we will keep the object as various positions. So first image formation is for the case when the object is at infinity. What do we mean object at infinity? Object at very far away distance, like sun. Let us say we want to form the image of sun using the mirror, right? So sun is very far away. So those kind of objects are called at infinity. So for example, before that, everybody's done this.
Yes, sir.
For convex mirror also, huh? Or take it as a homework. If not completed here, do that as a homework. Let's study this. So you have now a concave mirror. So what will you do? First mirror, then this point should not bulge out. Point is on the mirror itself. Then principal axis. Then here C and F. So just mark this point, don't label it. Label it later on. Because sometimes the ray crosses the written label. So you label the diagram in the end. Okay, but know the point that this is C and this is F. So when the object is at infinity, let us say like sun. So all the rays will come parallel to principal axis. Like this. Okay. All the rays will be parallel to principal axis above and below the principal axis. Okay. So for image formation, we require at least two ray diagrams, two rays. In this case, all the rays are parallel only. So we'll take one ray above the principal axis, second ray below the principal axis. So what will happen after reflection?
It will go through focus.
It will go through focus. So let's take the upper ray. It will go through focus like this. This is the first reflected ray. No need to draw the normal. Now we know that it goes through focus. What about the second ray? Also, it will go through focus after reflection. Okay. So what is happening to the reflected rays? They are after reflection, both the reflected rays are meeting or converging at F. And I told you where the image formation takes place, where the reflected rays either meet or appear to coming from a point where the extended rays meet for virtual image. So in this case, what kind of image formation takes place? The reflected rays actually meet physically. Real image. Now you remember? Now see what I had told you for real image. What description you have taken? Real image is found at a point where reflected rays meet after reflection. So they are meeting where? At focus. So for when the object is at infinity, where is the image obtained? Image is at F. Image is at principal focus or F, that is principal focus. So F is the point. Okay, this is where the image is obtained. So image is principal focus. What about its nature? Real or virtual? Real. So whenever the image is real, it is always inverted. We'll say real and inverted. What about the size? Huh? So this is position where the image is formed. Nature, real and inverted. And size is diminished or highly diminished? Highly diminished. Why? Because it is diminished to a point or diminished to a point. You see, we said these rays are coming from sun. Sun is such a big object and mirror is so small, right? So, although the object is so big, but what about image? It is point size, correct? So, we say image is highly diminished. Is that clear? Is there anyone to whom it is not clear? Please ask. Clear? Explain karo. How the image formation is taking place. So I told you for image formation, we have to take two incident rays. When the object is at infinity, only rays parallel to principal axis are possible. Okay, so we have taken two rays, one above and one below. And we know when the rays are parallel to principal axis, after reflection, it will pass through focus. That's it. And when it passes through focus, it is meeting at focus itself. Right? So the image will form at focus. So now we write down what is the image position? Focus. What is the nature? Since the rays are meeting, therefore it has to be real. And every real image is also inverted. It will not be erect like virtual. It will be like this. Okay. And what is the size? Size you can see it is small. What kind of small? Highly diminished. As compared to sun, it is a point, so it is highly diminished. Okay. Now second. Now there is a pattern in where we are keeping the object. First object was at infinity, far away, very far, right? So this is the symbol for infinity. Second, we are keeping the object. Where will we keep object? Beyond C, right? So what positions are possible? Infinity, beyond C. Matlab, when we are seeing it from the mirror, it is beyond C. Then at C, between C and F, then at F, then between F and P. These are the 6 image positions possible. Okay, so it's very simple. You don't have to memorize it. First is infinity. Then what are the reference points? C, F, and P are the reference point. The next point is beyond C, here, somewhere here. After that, at C. So third position is, object position is at C. After that, between C and F. Okay, that is 4th. 5th is at focus. 6th is between F and P. Clear? So the second image position, beyond C. Object beyond C. Okay, let's draw the ray diagram for this. So what will be ray diagram? So first step is to draw the mirror, mark pole, mark C and mark F. Now where is the object? Object is beyond C. So let us say we keep the object here. So we show the object as a vertical arrow on top of principal axis like this. And we name the object as AB. Okay, AB is our object. Now, if this is the object, I can see the whole pen, right? That means every point on the object is reflecting light. But I don't need to do that. I will only consider the top point. So let's take 2 rays coming from the top of the object, and then all the other similar plane rays can come out from the lower portion of the object, and the whole object can be reconstructed. So see what we do. Let us say we only take 2 rays, one parallel to the principal axis, and I know after reflection it will pass through focus. Okay, and second we will take through C. Either take through C, it will return back, or you can take through F, it will return back like this. Okay, so let's take the ray through C. So where is the reflected ray? We'll go back. So this reflected ray and this reflected ray, they are meeting here. Right? So where is the image found? Image is found like this. So for these 2 rays, it met here. You take any other ray. Now label C and F and P. So what is the image position? So where is the image? Image between C and F. For every object position, we have to identify what is the image position, what is the nature of image, and what is the size of image. This is what we have to do. So image is between C and F. What is the nature now? What is nature of image? Huh? Only 2 types of nature, real or virtual. What is it? Real and inverted. Why real? Because the reflected rays are meeting. That's why. And you can now see it is inverted. Okay? So real and inverted. Then what else? What about size? Diminished. This type, it is not highly diminished. It is only diminished. Because you can see object is bigger and image is smaller. It is diminished. Okay, so there is a reason why we are saying what we are saying. Okay. Next, third position. So can you try when the object is at C? At C. What will happen now? So everybody try. Yes, anybody? What is the first step? You go on the mirror. Mark 4. Do the shading. And draw the principal axis. Then mark C and L. Now you are keeping the object at C. Label it as AB. So which first ray you will take? Parallel. So this is parallel. Then you have this is the reflected. Okay, this is the reflected. Then what? You can take it through as this mirror is curved more inside. So the diagram if the mirror is symmetric. It is parallel. Now the thing is, it should come exactly below this. Okay. So for object at C, the image also will be obtained at C. So since you know it, you can do some manipulation to get the image just below C and same size. So this will be A dash and B dash. Okay. So the image is like this. Is that clear? So this is how you draw it. So what is the position, nature and size?
So distance between AB and B dash is
Anybody has new NCERT book? You will have image for it. Volume in the volume, do they have they given us rate diagrams?
Yes.
The volume is there, right? Fine. Which page is that? 20? So next page. Okay. Okay. So tell me, what is the image position at C? What is image position at C? It is at this point only, C. Okay, so we say at C. Now, nature, real and inverted, because this reflected ray and this reflected ray, they are both meeting at this point. Real and inverted. Then what about size? Yes. Same size as object size. Okay. So what pattern you are seeing? The pattern is when the object is far away, the image is at focus and highly diminished. As the object comes closer to the mirror, the image shifts away from the focus and it starts magnifying. Okay. So earlier it was point size, now it is bigger than point size. Now it has become same size. So what do you expect next? When I keep the object between C and F, it should be magnified. Okay, so this is the pattern. Starts from F and the image is shifting away from the mirror. Object is coming closer and image is shifting away. Now when object is between C and F, image should be beyond C. Got it? This is the pattern. Now let's do that. So can you draw it? Object between C and F. Right? This is 4. I've told you, image should be beyond C and it should be magnified. Can you try? Everywhere they have chosen 2 rays. So any 2 intermediate rays you choose. I try to draw the diagram of object between C and F. Here, you can see the order. What about the next ray? We take it to focus. That will be fine. So now we have object between C and F. So one ray you can take like this. Okay. There are two ways in which you can take second ray. So one is you can take along the center of curvature, but then for that you have to have a full mirror. So you take it either through principal pole or through air. Any one of these rays you can take. So it is cutting it over here. This is AB, right? If you would have taken at pole, let us say here, then also it will cut it at this point only. If you take the ray at pole after reflection, that also will cut here only. Okay, so you can take any two rays. There is no difference as far as the image formation position is concerned. Position, size, nature, everything is same. So this is B dash, A dash. So where is the image? Beyond C. Image position beyond C. Okay. Then nature is real and inverted. Right. What about size? Magnified. So you see, first was highly diminished, then diminished, then same size as object. Now it is magnified. So image size is increasing and it is going away from F as the object is shifting closer to it. Okay. So next two cases are special cases. Is everybody clear till here? Next is when object is at F. Object is at F now. Okay. This is A, B. So as usual, first ray parallel to principal axis. After reflection will pass through focus. Okay. Second ray you can either take through pole. You take it through pole, it will be parallel. Okay. Or you can take it along C. So you can like this. So take it along radius of curvature. So after reflection, it will retrace the path and it will pass through C. Okay. So the reflected ray you will see is parallel to the reflected ray. The second reflect, both the reflected rays are parallel. So where do parallel lines meet? Never meet, or we say it meets at infinity, right? So the rays, reflected rays will meet at infinity, or we don't know, right? So this is a case opposite of first case. Let's call this as. What was the first case? When the object was at infinity, that time the image was formed at focus. Now when the object is at focus, the image is formed at infinity. Okay, reverse of first case. So image at infinity. What is the nature of image? Real and inverted. Why real? Rays are meeting, but we are saying that they are meeting at infinity, right? So all the images formed in front of the mirror are real. So far, in all these cases, where are the images forming? In front of the mirror. What is front of the mirror? This side. Wherever the object is placed is front of the mirror. And this is behind. So as long as image is forming in front of the mirror, we will say it is real and inverted. For mirrors, for lens it is different. So real and inverted. What about size? Highly magnified, because you see this is the principal axis, and as you go towards infinity, the image size keeps on increasing, right? So that's why we are saying highly magnified, because we don't know infinite, it's a big distance, right? So it is now highly magnified. Opposite of first case. Opposite of first case. What was the image size in first case? So it is highly magnified. Right. Next. Sixth. Object between S and P. So till here the pattern is followed. Infinity से लेके F तक the image size is going on increasing and shifting away from focus. But now the pattern will change. Look here. Let us say this is the mirror. This is your hole. Okay. So what do you have? Where is the object kept? So this is C and F. The object is kept here. Okay. So again, take a parallel ray to principal axis. After reflection, it will cross. It will pass through focus. Now the second ray you take along radius. So after reflection, it will pass or retrace the path, right? retrace the path. Retrace the path. So when it retraces, how it will come back? Come back through C. And now they are diverging. Are reflected rays parallel? No, they are diverging. So if they are diverging, you extend it backwards. This is the principal axis. All fans. When you extend it backwards, so if this is AB, the image is, where is it? Front of mirror or behind mirror?
Behind the mirror.
So behind the mirror. So what is the nature of image? Virtual and erect. And what about size?
Size is magnified.
It is magnified, not highly magnified, just magnified. So image position, image behind mirror. Image is formed behind mirror now. Right. Nature is virtual and erect. Okay, and it is magnified. So you must have noticed all kinds of image formation take place in concave mirror, right? Real, virtual, then size wise it is highly diminished, same size, highly magnified and magnified. Okay, so all possible images take place in case of which mirror? Concave mirror. And when we discuss convex lens image formation, similar. The kind of image which is formed in concave mirror, same type of images will be formed for convex lenses. Okay? So if you understood this, now you are done. Right? All ray diagrams are similar. Okay? Okay, so how much time we have? 10 minutes roughly. Huh? Okay. So we can discuss the image formation by convex mirrors also. There are only two cases for convex mirror, right? So let's quickly do that also. Do you have any questions in this? So any difficulty? So there is a pattern. Once you decode the pattern, the image position is predictable. Okay. Now let's discuss image formation by convex mirror. Convex mirror. So it has only two object positions, object and infinity. So object at infinity. So convex mirror is, first thing you'll do is draw the convex mirror. Mark, pole, mark the shading, and then draw the principal axis. So the principal axis should extend on both sides of the mirror in this case. Because for convex mirror, The center of curvature and focus is behind the mirror. Okay. So this is how it is. ओए, क्या हो गया?
No pencil.
थोड़ा इधर शिफ्ट हो जाए. So so now for object at infinity, what kind of rays will travel towards mirror? Rays parallel to principal axis. And I told you, if it is parallel, then it will now not converge along focus, it will be reflected away from focus. Right? So likewise, you take a ray below the principal axis, and again it will be reflected away from focus. So these are the two reflected rays. Where are the two reflected rays? Like this. It is diverging. Everybody, look here. Where are the reflected rays? Away from focus. So in such a situation, we will extend the reflected ray backward. And we see that they meet at focus. That's it. So when the object is at infinity, you only expect parallel rays. So what is the nature of image? What is the image equation? Image is virtual and highly diminished. And what is the size at focus? So image at focus. Okay. Then it is virtual and erect. So whenever the image is virtual, you will always say erect, because virtual image is always upright. Okay, erect nature. And it is highly diminished. Okay, diminished to a point. Either you say highly diminished or you say diminished to a point. Who is there? So it is diminished to a point. Now next object position is in front of the mirror, because all the other points are behind the mirror. Okay, so anywhere in front of the mirror, beyond P. So you can say object beyond P. Okay, so the first point is P, the pole. So again, you draw the convex mirror. Can I erase this? Am I going too fast? Okay, let me know if you feel I'm going fast. So draw the principal axis on both sides of the mirror. Mark C on F. Let us say the object is in front of mirror. Okay. So first ray you will take is parallel to the principal axis. That will go away from focus. The second ray you take towards C. That is along the radius of curvature. So then it will be reflected back, because it can't go behind mirror, it is reflected back. Okay. So where are the two reflected rays? One here and one this. So you extend it backward this one. So these two reflected rays appear to be coming from this point. So this is your virtual image. So if this is AB, this is A dash, B dash. So where is the image forming between P and F? Behind the mirror, right? So image between P and F behind the mirror. Okay. And what is the nature? Virtual and irreal. What is the size? Diminished. Right. So in convex mirror, the images are only diminished and virtual. Only one type of image formation takes place in convex mirror. Okay. So next class we will see the uses of these type of mirrors.